Good evening, everyone, and welcome to Strait Science. Strait Science is an evening seminar series put on by University of Alaska Fairbanks Northwest Campus in Nome, Alaska, and University of Alaska Fairbanks Alaska Sea Grant, also in Nome, Alaska. And you're in the home office tonight. Both Northwest Campus and Alaska Sea Grant, we are public servants of the Bering Strait region. We serve all peoples of the region, and that includes Inupiaq, St. Lawrence Island Yupik, and Central Yupik peoples, for which this Bering Strait region is the homeland and waters for the peoples of just mentioned. So tonight we're very excited. This is a very good Strait Science topic because 2 weeks ago we had the NOAA Race Division give the results of the bottom trawl survey of the Northern Bering Sea, and that was very interesting, their results. But tonight we're going to hear the 1-2 punch, the second half of that, which is Jim Murphy's going to give us the preliminary results from the 2025 Northern Bering Sea ecosystem and surface trawl survey. So we should be getting, if you've watched both of those and been tuned in, this will give us a sort of the rest of the story for our ecosystem, our marine ecosystem. Now, Jim Murphy is no stranger to Strait Science. He's been on several times before. Jim Murphy is a research biologist with the NOAA Alaska Fisheries Science Center in Juneau, Alaska, and leads the surface trawl surveys for the Northern Bering Sea. So, Jim, we're so glad you're here. And please take it away. We want to hear, what were your results of the surface trawl surveys for the Northern Bering Sea? Thank you so much.
No, thank you, Gay. Yeah, no, it's good to have an opportunity to provide folks in the region with some of the updates on the Northern Bering Survey. I'm mainly just going to cover a couple of key time series of both ecosystem and fisheries data from the survey. But even though it's just my name on the title slide, I want to point out that there's a whole team of scientists that are required to make this survey happen each year. And I just want to make sure I thank all of the investigators and collaborators who have contributed to the survey over time. And I also want to thank the Alaska Sustainable Salmon Fund and ADF&G for their continued support of the survey. So this figure here shows the survey grid and some of the spatial strata that we use to delineate the different regions of the survey. The survey was conducted aboard a chartered fishing vessel, the Northwest Explorer. It started and ended in Dutch. The survey started August 30th and ended September 23rd. And we had a port call in Nome. We usually come into Nome halfway through, came into Nome on September 12th. We also briefly stop in Nome to offload frozen samples. And Jen Bell with the ADF&G office has been a big help during the port call, helping with logistics and assisting with shipping our frozen samples out of Nome. And so for next year, we'll have a similar grid, but I want to point out that we will be adding an additional 6 days to the survey starting in 2026. And this will be to support the Northern Bering Sea Integrated Ecosystem Research Program by NPRB. And so the additional 6 days will provide more complete coverage of the Bering Strait, and will also include stations further offshore in the region south of St. Lawrence Island. So we'll get a little more broader coverage of the Northern Bering Sea. Obviously, we're not able to really sample the entire region, but we'll get more a broader coverage in starting in next year, and that will be for the next 5 years, we'll have expanded coverage of the Northern Bering. Okay, so this picture here is the crew, both the scientists and the ship's crew from 2025. I was the chief scientist, and Rob Surian and Steve Porter were they served as deck boss, and they led the benthic sampling and research, and most of the non-salmon research on the survey. Carolyn Lawrence, who is also from Juneau, came on both legs with me, and she's mainly helping with the water collections and overall survey operation. Zach Liller and Marco Gutierrez from Fish and Game came out to assist with the salmon research and also with the deck operations. And Lauren Rogers from Seattle and Melanie Paquin from Seattle also led the zooplankton sampling. And Tamara Zeller and Dennis Marks from the U.S. Fish and Wildlife Service was on the survey to lead the seabird research. Captain Adam White and the rest of the crew, the exceptional crew of the Northwest Explorer, helped make it another successful year. And they've always been integral to all of the science operations. I'm navigating between two screens, so this is a different way of presenting this year. So we do multiple operations at each of those station locations. The first operation is the C2D, which is conductivity and measures salinity, temperature, and depth. So that gives us the water column properties, and we add multiple sensors to the C2D to measure dissolved oxygen, chlorophyll, fluorescence, turbidity, and we also have a rosette water sampler. So that you can see on this picture, it's this large cage with all these bottles on it. So we can collect water at multiple depths. And from the water collections, we'll again collect information on phytoplankton, but we also collect information on eDNAs or environmental DNA, nutrients, and food web tracers and other samples as they're requested. So every year, sample requests will vary. So we try to support as many of the sample requests that are submitted to the survey every year. We also collect information on the sediments with a benthic grab. This is the day grab that we deploy at every station. So we'll measure information such as sediment grain size. We'll look at harmful algal bloom cyst densities, and we collect benthic organisms for stable isotopes, fatty acids, and harmful algal bloom toxins. Excuse me. We collect information on zooplankton larval fish with a bongo net. It's like a bongo net array. So we get two different sizes. You can kind of see these two different sizes of bongo nets, 20 centimeter diameter bongo nets and 60 centimeter bongo nets. And we complete rough counts on the zooplankton on board the vessel to provide that rapid assessment of the abundance of at least the copepods, so large and small copepods. But we also preserve zooplankton samples for detailed laboratory-based counts, and also samples are frozen for various research projects as they're requested from year to year. We've added a small mesh beam trawl, and that's sampled at every station. This small mesh beam trawl is very effective in capturing the smallest life history stage of fish. and crab, snow crab in particular, as well as other invertebrate species such as shrimp and mysids and similar small invertebrate species. And the last operation that we conduct at each station is a surface trawl. This is a fairly large midwater trawl that we tow for about 30 minutes at each station. And this trawl is very effective in sampling the pelagic fish species like salmon, capelin, herring, pollock, and saffron cod. So some of the results here, we collect information on the temperature, and this would be the average temperature in the upper 10 meters. So it's kind of a depth average sea surface temperature measurement, not necessarily just the surface layer itself. The dashed line here is the recent temperature average over the last 20 years. And the solid black line is the long-term average in the Northern Bering Sea. Obviously, recent temperatures have warmed, so it's the average temperature. It's really important when you refer to as if temperature is above or below average. It's like, well, what time period are you referring to? So as you can see, really the surface temperatures have steadily declined in the Northern Bering Sea since the peak in 2019. However, we did see temperatures return to slightly above average in the recent average in 2025. And so that change in temperature has had an impact in the abundance and biomass of the different species that occur in the Northern Bering Sea. So this is the rapid assessment of zooplankton. There are two groups that we will measure on board the boat. That is large copepod species. That's the figure on the lower left, probably a little hard to see. And small copepod species, which is the figure on the upper left. And both of them had abundance levels declined from last year, but still just slightly above average. So in general, I would say the zooplankton abundance was average in 2025. And the figure on the lower right shows the lipid concentration or the quality of copepods. And this is just for large copepods. And it might be a little hard to see, but the lipid levels were very close to average in 2025. So in general, I would say that overall prey abundance and quality were very close to average this last year. One of the key salmon time series that we've monitored in the Northern Bering Sea is the abundance of juvenile Chinook salmon. And the juvenile Chinook abundance is used to provide forecasts for future run sizes to the Yukon River. The abundance of Chinook salmon has steadily declined over time since its peak in 2013. And last year they reached their record low abundance. And so it was pretty bleak after last year. However, this year, we saw a significant increase in their abundance. And the parent year escapements or spawning stock was very similar in 2024 and 2025, very, very low spawning abundance, but very comparable. And so this increase in juvenile abundance indicates a significant improvement in their overall survival or productivity. We'll have to get information on the stock origins of Chinook, but that will provide us a much clearer understanding of the survey data in 2025 once we're able to identify the specific origins of Chinook salmon. So this figure here shows the forecast model for the Canadian origin stock group within the Yukon River. It's a relatively good relationship. There's a couple of years that kind of stand out as outliers, but those are years in which we've had some, I think, complications in our survey. So it really reflects more of a problem in an incomplete sampling of the Chinook in the Northern Bering Sea. And then the figure on the right shows the forecasts for this stock group. And so it is, the forecasts are for declining run sizes. It'll take a while. It'll take about 4 years before the fish that we saw in 2025, before they return to the river. But hopefully that we'll begin to see a different trajectory for Yukon Chinook salmon here in a couple of years. The other thing I do want to point out is that this model doesn't account for the ichthyophonus disease in Chinook salmon from the Yukon River, and that is obviously a big factor. You can see in 2022 and 2023, the runs came in just right at the lowest prediction range of our forecast model. And so while there's a fair amount of work going on trying to understand ichthyophonus and how it affects their survival, if ichthyophonus continues to be a significant factor in the future, then these outlooks are actually going to be much more optimistic than what we would expect the run sizes to be for the Yukon River. And so we're working on trying to incorporate ichthyophonus into our forecast, but it's a fairly dynamic and complex process, so it will take a while before we'll be able to include those corrections in the forecast. Perhaps on a little brighter note, the abundance of juvenile chum was only slightly below average, and we've seen a number of years that have been well above average for Yukon River chum. On the other hand, what we've seen from our ecosystem research is that the condition of chum salmon and the quality of their prey fields is as important, if not more important, than the abundance of the juveniles. But we have seen the energetic condition of chum and the forage quality has improved quite a bit since the marine heat wave years and since 2019. And so with an improved condition of the chum salmon and at least average abundance, I think it indicates a positive outlook for chum salmon in the Yukon River. We're still working on developing forecast models for chum salmon, but I think in general this is relatively good news for the outlook for chum salmon. The abundance of pink salmon was well above average, a pretty significant increase from last year's abundance. And so this is expected to contribute to higher returns next year in 2026. Ben Gray from Fish and Game has developed this forecast or the relationship between juvenile and adult abundance. It's a relatively good relationship with the exception of a couple of years. And it looks like there may be some nonlinearity in this relationship, but we'll continue to monitor the relationship between juvenile adult abundance, and this will help us improve our understanding of the production dynamics of Norton Sound pink salmon. This model is specifically for Norton Sound pink salmon, although our juvenile abundance is for kind of all the pink salmon within the region. And so that kind of mixture of both mixed stock, trying to predict returns to a specific region, could also be part of this nonlinearity in the model. Um, this last year, we saw the highest abundance of age-0 pollock in the Northern Bering Sea than we've seen since the start of the survey. Now, age-0 pollock are distributed throughout the Eastern Bering Sea, and we typically only sample the northern extent of their distribution in Northern Bering Sea, so these north-south shifts in their distribution could play a key role in their biomass. And often that north-south shift is related to temperatures. Now, we've seen much warmer temperatures in the Northern Bering Sea, but we haven't seen such a comparable increase in their biomass. And we're kind of still working on disentangling shifts in their distribution or temperature shifts in their distribution and biomass, and how that affects their catch in the Northern Bering Sea. But we'll have to sort that out before we can really understand the context of this time series in the Northern Bering. And the final data slide I want to highlight is the abundance of forage fish. So herring and capelin are the two key forage fish species in the Northern Bering. The abundance of herring, or the biomass of herring, has remained below average since 2019, and that was the marine heat wave. And since there are multiple ages of herring in the Northern Bering Sea, their biomass is likely to be slower to respond to improved changes in survival. And we might be seeing some prolonged impact of past marine heat waves. The biomass of capelin in Northern Bering Sea is strongly affected by their north-south shifts in their distribution. But there's also a survival component to that. We did see a fairly significant increase in the biomass of capelin during the cold conditions that we saw last year, but their abundance dropped pretty sharply in 2025. And this likely represents a response to the warming temperatures or the above average temperatures that we saw in Northern Bering Sea this year. So I'll end with a few photos of the folks that have helped contribute to the data that I've shown here, and help to make this survey happen every year. And if you have any questions, I'd be happy to answer them.
Okay. All right. If I can click the right buttons, there we go. Well, thank you, Jim. That was well done. Now, for the Strait Science audience, this is the time that we thank the speaker for giving us a quick overview of what happened on the Northern Bering Sea surface trawl survey. So show a little love for Jim Murphy in the chat, and we'll open it up to questions. All right, Alex, you've got the floor. Go ahead.
Yeah, Jim, nice presentation. How much do you think the trend in temperature changes in the Bering Sea is affecting the distribution within your sampling area?
Yeah, so it really depends on what species. It varies by species. I'll give you an example. Like one thing I've seen with Chinook salmon, which I follow that a little more closely than the other species, is the colder temperatures tend to keep the Chinook closer to shore, and they will tend to disperse out of the Northern Bering Sea quicker in cooler years. It's not, I don't know to what extent you can actually predict that. And some of it could just be, it's complex because you can have warmer coastal areas, but still have a cold pool that could end up in a situation. But I would say in general, when you have very, that cold pool is very limited in its size, that tends to, they disperse further offshore, and they tend to hang up in Northern Bering Sea longer. Now, obviously, for age-zero pollock, we'll tend to see more age-zero pollock in the warmer years. They disperse out of the Southern Bering. Capelin disperse more into the Chukchi Sea in warm years. So it really has a fairly significant effect, but it's difficult to disentangle changes in their distribution from changes in their survival, especially for stocks or species in which you haven't sampled all the way through their population, such as capelin and pollock. Do you have a follow-up
That answer the question?
Well, that's real good. Thank you.
All right. Alexei, you have the floor. Go ahead.
Thank you, Jim. Great talk. I got two questions. First, one, I'm interested in the main rivers of chum and pink salmon that you sample in the Northern Bering Sea. So I know that Chinook salmon come from Yukon River, but what about pink and chum salmon? Are they local or they migrate from some adjacent areas? This is the first question. And the second question is regarding H0 pollock. Did you come across some other evidences that the abundance of H0 pollock in 2025 was very high? For example, from bottom trawl survey or acoustic trawl surveys that NOAA also conduct. Thank you.
Yeah, thanks, Alexei. So for chum salmon, there are some chum salmon that are produced from Kotzebue Sound. And some potentially are coming from Russia as well. And I think that's true for both chum and pink salmon. So when based on the genetic stock composition of chums, juvenile chums, most of the chum salmon in the Bering Strait tend to be from non-local stocks. In other words, Kotzebue Sound or Russia. And in general, what you will find for salmon is that they come out of the Yukon and Norton Sound and they head south. They swim against the prevailing current because they have to exit the Northern Bering Sea to the south to get to not get trapped in the ice. And I think that is made a little bit more clear when you have species like Chinook or even coho salmon, which there's not production in Norton Sound and Kotzebue Sound, or really very little, if any, production from the Russian side. And you can see that those two species are all distributed south of the Yukon River. And of course, pink salmon, we can't distinguish where they're from, but we can for chum. So I'm assuming that pattern that we see in chum is going to be true also for pink salmon. And then, okay, so the other question is age zero pollock. The problem is in every other year, we do have surface trawl surveys that are conducted in the Southern Bering. Unfortunately, in this year, we didn't have a survey there. So it would have been nice because if they also were seeing record abundance, it'd be a little bit easier to understand that significant increase in catch of age zero pollock. The bottom trawl survey really doesn't sample age zero pollock. They will sample age 1. And so I think our first indication of whether this increase in the catch of age zero pollock is indicative of a strong year class will be from next year. And if they see a significant increase in age 1 pollock, I think that would align quite well with what we saw on our survey. Can't hear you, Gay.
I was just story of my life. Leave it on mute. Alexei, did you get the answer, or do you have any other questions for Jim?
No, I have no more questions. Thank you very much.
All right. And I'm about to put in the chat the Northern Bering Sea Bottom Trawl Survey Community Highlights Report, which is not citable, but I'll just stick that. I'm typing it up and trying to get it. And that'll have some biomass estimates for the bottom trawl survey. And I have a question for Jim, but waiting impatiently is Isaac. Go ahead, Isaac.
Hey, Jim, thank you so much. I was trying to make a meaning of the prediction with the abundance of the adults and then increase in juvenile, but I wasn't able to look at the figure well. So if you can just throw more light, if there's increase in adult, that doesn't have effects on the juvenile increase also. But I was trying to look at each the hot point, so I couldn't really figure it out.
Yeah, what species were you interested in?
Like you showed a figure that has an abundance of okay, adult and in the desk versus yes. I was trying to see whether okay.
Yeah, so this figure here, sorry, it's a little bit busy. I grabbed this from Ben Gray, and he was looking at different types of models, and he was just saying that the generalized additive model provides the best fit for this. This is the abundance index of pink salmon and the adult returns to Norton Sound.
What does the GAM refer to?
Oh, yeah, sorry. It's generalized
General
additive
model. Okay, so
yeah.
Thank you. Not being a modeler, I'm learning. Thank you.
Okay, thank you so much, Jim.
Yes.
All right.
Does that answer your question?
I think it did. I think he thanked you for your response.
And okay. You're welcome.
Isaac, your hand is still up, but that's okay because it just matters which button you're pushing nowadays. So
thank you, Gary.
You bet. So I have a question, Jim, and that is, we heard from the bottom trawl survey, and I put the community highlights report in for the bottom trawl survey. And in there, when you said herring were down, the bottom trawl survey had I think a large increase. The bottom trawl survey said they had a 200%, over 200% increase in biomass. Are you guys looking at, I know you're targeting different parts of the water column, but are you targeting different age classes as a result of that? Why would
Was that just in the Northern Bering Sea, or was that the the total Eastern Bering Sea biomass of herring?
this is in the, I put it in the chat, but in the I guess they're looking at 2023, the percent change between the 2023 and 2025 Northern Bering Sea surveys, blah, 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 for the Northern Bering Sea, because 2024, only the Eastern Southern Bering Sea was surveyed. So for us up in the north, it would be a comparison between 23 and 25. And they have Pacific herring percent change between the years was 203% increase. And I was just wondering, shucks, is it different size fish because you're up in the surface, so you're maybe dealing with younger fish, or is that?
Yeah, I mean, some of that, I think herring, it can reflect a change in their vertical distribution.
Okay.
You know, they could be more on the bottom. We catch a lot of the age 0 herring, which they will unlikely catch. So yeah, different ages and different parts of the water column. Maybe what we should do is combine our indices to to kind of get a better, more complete picture. But yeah.
And we can talk later on how they present their results. They actually give the age, the lengths, so you can kind of see age class. But the other one on that would be for the pollock. So if you can go to your pollock again slide. So I remember you saying you were surprised by how many young pollock you were seeing in your survey. And also for the Northern Bering Sea, I think they said they had like a 51% increase in the biomass of pollock for the bottom trawl survey. And I think they were small, very small age class, right? So that would align with what you saw, these age 0. And I'm just wondering, because pollock is kind of we had the big pollock arrive en masse like we've never seen before in 2017, 2018, 2019, when the heat wave, we had such poor ice, we lost our thermal barrier between the Southern Bering Sea ecosystem and the Northern Bering Sea ecosystem, and all those Pacific cod and everybody came rocketing north and really gave our different ecosystem than the Southern Bering Sea, gave our Northern Bering Sea ecosystem really a lot of pressure, right? We had all these large-bodied predators, things like that gobbled up, or that warm water caused our small fatty forage fish to leave, either they were eaten or they ran for the ice north. If those young pollock, number one, what do young baby pollock eat? Is that a problem for our salmon? That would be the first question for me. And two, what if they survive this winter? When they're a 1-year-old pollock, what happens there? I would assume that's a lot bigger fish. And are they going to be, what should we expect? What do they eat when they're small? Like what happened this summer here when you saw so many, and the bottom trawl survey also saw the same. And two, if they survive the winter, what should we maybe expect to see for our ecosystem up north? Is that?
Yeah. Well, there's a couple of things there. It just depends on what species of salmon that you're concerned about.
Any.
As to, yeah, you're not going to see large overlap. I would assume, species like sockeye, possibly pinks, will have a greater overlap with pollock, but other species like chum, they tend to feed more heavily on gelatinous zooplankton, but they're fairly placid in there. They'll eat what's in front of them to some degree. But you're not going to see this direct overlap. For coho and chinook, they largely feed on larval fish. So you're not going to see a lot of overlap between like A0 pollock and chinook and coho. But there will be different degrees of overlap. The one thing that's really important to recognize is that age 1, age 0, even the other older ages of pollock are really not going to survive under the ice. They're just not. They all have to like come south. In order for ice to form, the entire water column has to drop to negative 1.8 degrees C. If it's warmer than that, then ice is not going to form. So I think age 0 pollock will tend to have some tolerance to cold temperature, but they're not ice adapted. So they will all have to come south with the ice. And so the potential impacts in the future is going to be more about warming in future years and movement of pollock north, not just because they were found or present in the Northern Bering Sea the previous year. It's all going to depend on, the warming of the Eastern Bering Sea and movement of the pollock, and that's true for age 0s on up. Does that answer your question? I think
kind of, and I know we've got Alexa. If you can be patient for 1 second while I figure this out. So on the all salmon, all pollock won't survive under the ice or have to come south. Know that we have a lot of heat in the water. Our ice conditions are poor on this side as far as quality, and in fact, the ice just pulled off. We had some north winds earlier today, are still going on, and the ice is like broken off at the beach. So our shore fast ice we have open water, right? And it's February. And so this is indicative that we've had some cold weather and it's very weak ice. So the other thing is we watch our neighbors to the north, and looks like people are trawling commercially up as far north as the central Chukchi. It looks like pollock trawlers. I don't know if those are research. We sort of figure those are commercial. Some of our processors look to be, and those are fishing kind of right on the correct side of the boundary, the maritime boundary, but they're as far north as Point Hope. So year after year after year. So as someone who lives in the Bering Strait region, are those pollock, have they made it? And I know we don't have any research on our side by NOAA that's been able to get up in there, and that's just the way it is. But do you think that the pollock are all coming south for the winter? They're pulling out.
Yeah. I mean, it's the reality of
Okay.
the water column and sea ice. Because if there's water warmer than like negative 1.8, that's because of the salinity in the area. It's because as it gets cold from the surface down,
Yep.
So as that water becomes cold and more dense, it'll drop through the water column and it'll get replaced with warmer temperatures. So you have to have the entire water column drop to that temperature before sea ice will form.
All right, I appreciate your answer. And then the other one is, what do those age 0 pollock eat? Would they eat smelts coming out or a smolt coming out of the rivers?
No,
Okay.
they'll eat small copepods and very, very small zooplankton. I imagine they'll eat large copepods too, but the copepods they're by far the most prevalent prey available, and typically their diet is in invertebrate. They can feed on some gelatinous, I think, but they primarily feed on invertebrates.
So we don't
With
have a concern that pollock. I always think of pollock as sort of a pod of her piranha fish, coming up to our gentle waters. But are do they ever eat salmon smolt?
No,
Okay.
not age zero. I mean, I don't even
No,
think
the older age classes, maybe
the
not.
older age classes. Yeah, they're, I don't know, maybe, but I think it's highly unlikely. The adult pollock will tend to be on the seafloor. They're going to be much
Okay.
more benthic oriented, whereas salmon are going to be up in the water column, and
Okay.
especially small salmon.
All right. I just had my, you know. All right. Thank you very much, Jim. And Alexei, thank you so much for being so patient. Please go ahead.
Yeah, I was just glad to listen such a comprehensive discussion. So, and after that, I have a small, short, and non-scientific question. So, who is the deck boss? It's very interesting for me.
Who is the deck boss?
Deck boss, yeah. And in the table of participants, you mentioned that Rob Sirian was a deck boss. What does it mean?
Yeah, Rob Surian, he's stepped up. So on the surveys, we have kind of two leads. One is the chief scientist who handles all the wheelhouse operations and planning. And then the deck boss is the one who's organizing all of the gear going over the side of the boat. And because we do a lot of side ops, a lot of oceanography, the benthic gear, and all the beam trawl work. So that's we distinguish between those two leadership positions on the survey. One's chief scientist, the other is deck boss.
And I think Rob Surian is on. Rob, do you want to show yourself so you can see what a deck boss looks like?
Yeah. You tell us about your experience of being deck boss.
Don't mess with the deck boss, I believe, when you're on the ship. He's the boss.
It's
Go
not
ahead,
letting
Rob.
me. It's not letting me show my video, so I
Oh.
can't show my
right.
face.
That's how powerful a deck boss is.
Yeah.
They don't even want to. They don't even want to know what they look like, so you can't see them coming.
The deck boss says, maybe it's too rough at this station. And the chief scientist in the wheelhouse says, oh, it's fine. Let's go.
Yeah. What are you guys complaining about? Okay, so
right.
there's
Thank you, Alexei.
There's the face of the deck box here, right under. I don't know
under
if you
the
can
word
see
Alaska.
Yeah, that's Rob.
With the gray sweatshirt on.
Yes.
We have Austin Amosic with his hand raised patiently. Thank you, Austin. Go ahead.
Yeah, hey, thanks. Great report. Here in the Nome area and just in general in Norton Sound, our salmon populations are severely depressed. Severely depressed. And this last week, hundreds of people testified that every salmon is important. We were arguing against salmon bycatch in the trawl fishery. I am wondering, have you investigated the impact of research that kills essentially juvenile salmon on systems like ours, if you're catching salmon from our systems that are, extraordinarily, like, severely depressed? They're greater than 95% less than historical returns. If we look at all the sources of mortality, commercial fishing, bycatch, predation, research, natural mortality, subsistence, does research have an impact if every salmon counts?
Yeah. And that's it's going to really depend on the species, of course, that you're referring to. Often it's Chinook salmon that is the front runner of that concern. And so one of the things that I can do, and what I have done, is taken the like the total catch of Chinook salmon, and that will vary depending on their abundance. But especially in these low years, we generate these abundance indices with catches of less than 100 juvenile Chinook salmon. So when they're really low abundance, our catches are like 100. And we know from the genetic information, our abundance estimates, and then the adult returns that, we have survivals of around 3 to 5%. So this is going to, our impact from our survey will, have impacts from 3 to 5 adults that return to the river. So it's not a no impact, but the information that we gain from these surveys is generally considered to be outweighs the impact that will have on the stock. That's kind of the general census for that. So I'm not sure if that answers your question.
Yeah.
Or answers your concern.
Yeah, thanks.
Answers your concern.
Yeah, I guess maybe just, in perspective, some of our systems in regards to Chinook, they might have returns of 10.
Yeah. And so the chances of us ever catching one of those is like so small. This is like for the Yukon where, they'll have returns of like 30,000.
So Jim, thank you, Austin. Any other questions you might have or comments for the speaker or the group? Okay. All right. Any other questions or comments for Jim Murphy? And we really are having, last summer, Jim, as you know, was very poor for our fisheries, our salmon fisheries. And as you know, everyone here depends on fish, salmon. And I think probably we could assume that it was difficult for our neighbors since we share the same waterway and probably share a lot of the same stocks of fish. So I'm glad we have good representation on tonight. We don't know, and we know you can't say, but anyway, know that it was a very poor fishing, especially for chums and pinks. That was a surprise for us. But it sounds like, Jim, are you saying that you're looking at small salmon, but are you saying when you said the numbers of salmon should go up or it'll be a better year, what age class roughly are you talking about? Next year is supposed to be a kind of a high year, I think, for our pinks historically.
Yeah. So this figure here shows last year, 2024, was the lowest abundance of juvenile pink salmon that we've seen in the entire history of the survey.
But 2008 and 2020, those are just non-survey years?
Yeah, those we didn't sample.
Okay, thank you.
But the difference is so for the 2024 survey of pink salmon, that is impacting the runs for pink salmon in 2025. But if you look at the index, pink salmon index in 2025, it just jumps. It's a huge increase in the number of juveniles. So that's going to indicate should indicate a significant improvement in the runs for pink salmon. And this model is specifically for Northern Sound pink salmon.
So catchable size, or when you say juvenile, I mean, I'm thinking.
So
I don't know your age class or your length or whatever.
A salmon is called a juvenile in their first summer at sea, regardless of their age. So pink salmon spend 1 year in the marine environment. So the juveniles that we caught in 2025 will be returning to Norton Sound this summer.
Okay. Great. Well, we look forward to that. And will you be returning this summer?
Yes.
When is your survey and what ship? Do you know yet what ship you'll be on? Is it still the same?
Yeah, we'll be sampling Northern Bering on the Northwest Explorer.
Okay.
We're adding 6 days to the survey, so it'll be 31 days, a little bit longer. We plan to be in Nome, I think at this point, we haven't set the date, but it'll be right around the 9th or 10th of September.
And Rob, I hope Rob Suryan, are you still on? Are you connecting with Jim Murphy? And for those that are outside of the region, this may not make sense to you, so bear with us. Is this also going to be part of the Northern Bering Sea's brand new integrated ecosystem research project cruise?
Yeah, Gay, still here. And yes,
Okay.
absolutely. So I am leading the proposal that was funded, but it's based on this survey, this exact survey.
Okay.
So, yep.
All right. I think the region here is going to hear a lot more about both of these efforts in the next 2 or 3 years. And so it's just great to try for our local understanding of how this is all being worked together so we don't get too much confusion. Like I can get confused on all these different efforts. So this is really great. So thank you. So when Jim's coming up, are you going to be the deck boss?
Yes, we're all one and the same.
Okay. All right. So it'll be a kind of a repeat of that. That's helpful.
Yeah. And Rob is, really, not only is he kind of really helping out with the survey, he's leading and coordinating all the research that will be done with this IRP.
Okay.
So he's gonna, and we'll be working on this for the next 5 years. So there'll be surveys every year for the next 5 years in support of this.
And then Rob, just one last question on this. So Sikuliak, the vessel Sikuliak is supposed to come up in September-ish. That is also part of this effort?
Yep. So the Sikuliak is the UAF portion of this project that has their cruise is this September, and it's a lower trophic level, physics, zooplankton cruise, and also putting moorings out. And that is, their cruise would be 2026 and 2028. And then there's another new NOAA cruise that's going to be 27 and 29. That's going to be a spring cruise, and that'll be on the white boat, the Dyson or the Shimano, one of the two white boats, the NOAA vessels.
Maybe I'll. Go ahead.
Yeah, no, go ahead. Yep.
No, keep going.
We still are working to put this integrated science plan together because we are 3 separate projects funded by the IRP. Now we're kind of forming this one big project, program. So there'll be much more material coming out to describe the program overall in the near future.
Wonderful. And I think that, again, sorry for the people outside the region, I think on May 14th, the North Pacific Research Board and the 3, including you, the 3 leads of this new effort that we're learning about, we'll be doing a Strait Science. So we'll be able to hear more about that effort. And it would be helpful for us to, all of us in the region, to understand who's doing what on what boat, when, who's in charge of these things, who's the deck boss of this effort. So thank you, because I think you're going to be a part of that. And it is confusing right now as we're learning, but it'll make more sense as we get more information brought to us as this is gearing up for becoming a reality, this kind of research going on. So thank you. And we look forward to learning more about the boats, the timing, the effort. And we really appreciate that. All right, Jim, I thought you were walking out. Don't leave yet.
Well, the lights keep shutting off here.
Oh, dear.
It's fine.
All right.
Just got to turn them back on.
With that, any other questions? Comments? Rob, go ahead.
Hey, yeah, I just wanted to mention, and also thinking about Austin's question, there's a lot of analysis and models coming out of this effort, in addition to with this IERP, this integrated program that's focusing on both groundfish and salmon. So there's a lot more to come, but there's also recently there was a integrated population model for Chinook salmon from using a lot of data from the region and from this cruise that Jim and I were both co-authors on. That is going to be published here soon, and it'd be good to that's something to watch out for, and we'll try to communicate that with the region as much as possible. But those are going to be some really important models and output to think about this whole ecosystem overall and how it's affecting salmon populations.
All right. Well, I hope it gets to it.
Yep.
All right. If no other questions, I will say we'll let everyone go, but next week on the Wednesday, it's going to be on a Wednesday next week, Strait Science, and that'll be February 18th. We're going to have for the speaker, the United States Marine Mammal Commission, which is the oversight agency for marine mammal research and management in U.S. waters. And so we'll have one of the commissioners, Sue Moore, her assistant, and we'll also have Vera Metcalf from the region, and who serves as I haven't written it down, but she's a liaison for Native Affairs, I believe, in her role with the U.S. Marine Mammal Commission. And they're going to provide a background on research and co-management activities underway in the Bering Strait region. So they're looking forward, and I'm looking forward to hearing what they have to say, and they're looking forward to a conversation. So tune in. Those notices will go out here pretty soon, and we'll see you next Wednesday on February 18th for the U.S. Marine Mammal Commission. With that, thank you to everyone who showed up, and we'll say good night, and have a good night, everybody.